A very warm good evening, good morning, or good afternoon, in whichever part of the world you are. I would like to welcome you all for today's hands on workshop on biomedical data science in Python. This course will cover practical and conceptual aspects of machine learning and data science in application to high throughput biomedical data using various tools and Python. Throughout the course, the students will get an understanding of the opportunities and limitations of data science and machine learning in the context of preclinical and clinical research. The course is designed as a combination of online resources, practical assignments, and live workshops that will be conducted online. Throughout the course, we will review several project examples that demonstrate the successes and limitations of conventional machine learning methods and deep learning as well using data from public repositories. To begin with today's hands-on workshop, I'll quickly first of all introduce myself and also our company, and then we may proceed ahead with the workshop. So I'm Sonalika Ray. I'm the bioinformatics project manager at Pine Biotech. And to introduce our company, we are a US-based bioinformatics company who is working with multiple and academic commercial collaborations to develop easy-to-use analytical tools. And our mission is to make bioinformatics more accessible. And over the past several years, we have had the privilege of working with a number of organizations developing a training program for research oriented students, faculty, and democratizing bioinformatics, making this discipline accessible to thousands of students and faculty around the world. Omics Logic research based training programs are a result of close collaboration between Pine Biotech and numerous academic institutions that have participated in content evaluation, curriculum review, and project design. The training follows a project based learning approach using research grade tools to analyze data from top peer reviewed journals. Omics Logic training has been completed by students, researchers, and faculty in 6 different specialization tracks, which includes oncology, infectious diseases, precision medicine, neuroscience, data science for biomedical data, and comprehensive training on omics data analysis. The training has been completed by over 24,000 participants from 187 countries and over 300 workshops. And due to this fast growth, our team is now working with local and regional coordinators that are helping refine the local program logistics and leverage our online training resources, adapting them to the needs of students and researchers around the world. I would like to introduce the founders and the team members of the company. Dr. Alfred Tauber comes from a medical background with an expertise in oncology, immunology, and biochemistry of inflammation. And one of his major projects is the establishment of Tauber Bioinformatics Research Center, which has been at the core of what we do. Dr. Leonid Brodsky is the director of Tauber Bioinformatics Research Center and is an expert in bioinformatics and biostatistics. And our platform is a result of hard work by some of the people who are mentioned here on the right. Dr. Julia Panav is an expert bioinformatician. Dr. Mohit Mazumdar is an experienced bioinformatician with multiple publications in peer-reviewed journals. Dr. Raghavendran is an accomplished computational biologist with an experience in large-scale analysis of multi-omics data and data science methods in precision oncology and protein DNA structural bioinformatics. All right, so now let's highlight some of the current challenges and limitations and how we at Omics Logic can help resolve these with our training and research services. So what are some of the challenges that the field of bioinformatics is currently facing? To begin, this field is constantly growing and developing new tech and software to improve processing time and power. The data sets that are analyzed are usually very large and take immense amount of computing power and memory that many personal computers do not have. Also, despite being publicly available, data is also usually complex to access and coding knowledge is usually required to do so. Similarly, analysis pipelines and programs require coding knowledge that many biologists do not have. In a university setting, students have the opportunity to learn the background information of designing and implementing a bioinformatics project, but do not receive practical hands on experience with the full workflow due to the limitations that I just mentioned. Similarly, faculty faces challenges with being able to cover a diverse range of topics if they are specialized in a certain area of bioinformatics or if they are unfamiliar with bioinformatics in general. For example, a professor whose research focuses on oncogene expression might not be much aware about metagenomics of seawater. To overcome these challenges, Omics Logic platform was developed. This platform aims to standardize, organize, and systematize bioinformatics training in order to make these analyses usable for any biologist or a clinician. Some problems for standardization includes materials for these courses that are usually developed in-house, taught sporadically, and are rarely updated. Organization, because the challenge is to combine several different topics together, the flow and transitions are needed to be developed. And systematization, how can you know that someone is stuck and needs help or allow someone to run forward? Omics Logic uses standardized modules and interactive sessions, beginning with mastering terminology and concepts to implementing these concepts with real data set in a project-based approach. So what is our learning process? In order to create a clear path of skill development, Omics Logic employs the Bloom's taxonomy levels of learning. This approach starts with the basics, where students recall facts and terminology and are able to repeat and memorize the material. With this base, the learning builds to conceptual knowledge, being able to understand concepts and apply information to new situations. The student will then be able to analyze data by drawing connections and evaluate when to use certain methods. This leads them to the highest level of learning, the ability to design and create original work. So, how do Omics Logic resources help advance bioinformatics teaching? Omics Logic is a portal for practical and theoretical learning of bioinformatics, which is composed of courses designed to take you through the theoretical knowledge. Omics Logic takes a combination of training modules, data analysis tools, curated project datasets, and interactive sessions with mentors to give a student a clear path up the Bloom's taxonomy pyramid. And no matter what the user's initial experience with bioinformatics is, Omics Logic is a useful tool for gaining a baseline knowledge of the theory behind bioinformatics, analysis of large data sets, and introduction to basic coding languages like R and Python, or beginning a data analysis project altogether. Users will be given directions to access the T-Bioinfo platform for bioinformatics processing and analysis of transcriptomics data. The platform includes demo pipelines as well as data management and analysis cloud infrastructure to run bioinformatics pipelines. Different stages of analysis are performed in different sections of this multi-omics platform. This program comes with an access to the Omics Logic courses, which includes an access to bioinformatics, precision medicine, multi-omics coursework, which includes genomic, transcriptomic, metagenomic, epigenomic data analysis, data science that includes bioinformatics using R and Python, and example projects or case studies, I must say, from different fields, which you could learn from and replicate for your research work. So first of all, let's begin by signing up on the Omics Logic Learn portal, where we'll be sharing the link of the portal in the chat box, and you can go ahead and sign in. Let us know through the chat box if you are logged in by typing in a yes. If you have already signed in, then it's good. You can let us know that as well. Once you have signed up, you need to make sure that you have a complete profile. A completed profile will include a profile image, full name with appropriate capitalization, link to your social media handles, which could include Facebook, LinkedIn, Instagram, org ID, and Twitter. A brief bio about yourself that will consist of educational background and research interest. The mentors can view your progress under the activities tab, and the courses you are currently completing will appear under the courses tab. Finally, after the completion of your course, the certificates will appear under the certificates tab. Now, I would like to give a quick demo for those who have just joined us for the very first time on how you can log in to the Omics Logic Learn portal. Sparsh has shared the link of the portal already in the chat box. You just need to click on the login button here, and either you can create or set up your credentials or use any one of your social media accounts and sign in. I'm awaiting for responses in the chat. If you have signed up or if you are signing in, please put a 1 or yes so that we can proceed ahead. Today is a hands-on workshop, so we'll be expecting you to follow the steps that the mentor would be taking you through. Today, we'll be running some code blocks from the Python coursework on the portal. And for that, it's important for you to have an access to the Python coursework. So once you log into the portal, we have 2 courses on Python. If you search in the search bar and type Python, you'll find these 2 courses that we have to go through. So please make sure that you are all set by signing in on the portal so that you can follow along the steps the mentor takes you through. We'll take 2 minutes before I pass on the session to Dr. Raghav so that he can get us started with the workshop. Just making sure that we all are set to begin with today's workshop. And for those who have already signed in, you can click on the mail address which says welcome back and then your email address. When you click on it, you will be redirected to your profile section. Please make sure that you have an updated profile so that we have a good background about your educational background and your research interest, and we can assist you accordingly. I see just 3 responses. We'll wait for a minute more if you're signing in. All right, I think we are good to begin with today's session. And now I would like to pass on the stage to Dr. Raghav to take the session ahead. Dr. Raghav, over to you.
Thank you very much, Sonalika, and welcome all of you to today's hands-on session on Python's course. Let me find ways to share my screen. Before that, so before that, let's get a quick check. How many of you have some experience in coding or specific to Python, etc.? If you are a complete beginner or a newbie, you can give a number like 0 to 2. And if you have moderate experience, like if you know how to, thank you. If you know how to plot 1 or 2 plots, like a box plot or like a bar plot, like a scatter plot, then you give it 5. And if you know how to find relevant codes from Stack Overflow or publicly available discussion media, and then modify those codes to your needs, and then present some decent plots, then have 7 and and above. So let's see, lot of numbers less than 2, and thank you very much. There is a 7, an expert there. That's good, experienced person there, and then some more entries. Okay, so this could be a little bit let's see, basic for people who are who have some experience. But again, I usually tell this to many people, always mention this in these webinars, that the focus is going to be using omics data type. So in spite of the fact that we have some experience in Python and we know how different tools and functions and modules and everything is being used in Python. Sometimes some of them might not be relevant for omics data analysis. Some different types of data wrangling and data analytics could be useful for omics data analysis. So yeah. Congratulations, Rohit. Yeah, welcome here to this session. So let's see how you interpret what we are going to discuss today. Okay, let's go over, for example, what are we going to learn in the in the program. So this program is focused on, for example, biomedical data science. So by meaning or by choice, all the data sets that you're going to deal with is going to come from biological data, mostly bioinformatics data from high throughput sequencing and structured data from omics data analysis for omics data analysis. So for those who are absolute beginners in bioinformatics and who does not know, for example, how these high throughput sequencing data is generated, in what are the different areas, research fields and translational application fields where these bioinformatics data analytics and bioinformatics applications are actually concentrated, then we have an introduction session and introduction resources lessons for you. So you will be required to go through introduction to bioinformatics lesson and bytes and molecules lessons. So what is this going to tell you? This is not a coding oriented lesson, excuse me, but this is going to be an introductory lesson and an overview lesson on bioinformatics in general. So if you come from a field that is not related to biology or biomedical science, then you can go through these lessons. And if you are from this, if you have some introduction to bioinformatics already, exposure to bioinformatics already, then still I would suggest you to skim through this lesson. Maybe some of the places where you think bioinformatics might not be useful and applied, we can cite you some instances where it's been extremely useful. Some interesting options such as, for example, wastewater surveillance that you already know for SARS-CoV-2, and for example, spaceomics, where a major part of research and interesting research has been carried out by NASA and other space agencies to understand space effects on humans and other model organisms. So these are all some of the places where we wouldn't have thought biological data could be used and applied. And after that, you also have an introduction to getting started with bioinformatics in Python. So what is this lesson going to deal with? So if you open these associated resources, right, it is going to take you to what is Python and how to install Python, and generally take any structured or table data and load it into Python's environment. That is what it is going to deal with, right? And we want to help you learn the methods with which you can understand the analysis and statistical methods and analysis that needs to be applied on omics data, right? Big data, right? Biological data. So the focus is going to be on the methods and less on the technical aspects of Python, for which you can refer elsewhere for that. So this is generally going to start with installing Python and some resources where you can find more detailed description of how to install Python, etc., etc. Okay. So the one that we are going to deal with today is about data processing and exploratory data analysis. And why did I choose this? Right? I chose this specific session and this specific lessons to discuss with you because I want to give you a taste of how data exploration in omics data analysis, for example, plays a key role in understanding patterns and in setting up what needs to be followed after these exploratory data analysis, right? In any analysis, right, in any advanced statistical or basic statistical analysis, you need to understand what are the relationship between the features, or what are the relationship between the variables that you have, so that you can plan what are you going to learn and what are the trends that you are going to focus on and what are the patterns that you want to understand, etc. And these becomes very important in the context of biological data, because one day the lesson that you are going to understand and learn is going to be converted into a drug, or is going to be converted into a diagnostics measure, or it is going to be converted into an app with which is going to suggest you your dietary plans. So it's going to be that important, right? So unless unlike other internet of things and other methods where you will get suggestions and other results based on your existing behavior. So we are not going to use for that. So this biological data or omics data comes with their own challenges, and this all the sessions here and this webinar, this program also deals with some of those challenges and how to understand uh, those limitations and also some advantages also in another cases, and how to use it to our own advantage to gain so that we can gain lot of information and lot of hidden trends and relationships from the data that we are focusing on. So let's go to this specific link. I'm going to share this link, right? You can access the lesson that we are going to discuss through multiple different modes, right? You can go to the program page, and then in the program page under the January 24th session, right, you can choose to click on data wrangling and visualization. So this link will work only if you log in and use the login credentials that you have just created or you have created earlier to log into the Learn portal that we have. So please log in and open this specific program page and click on this coding lesson, data wrangling and visualization. If you click, you're going to look at a page like this. And to more general way of understanding or more general way of reaching this lesson is through um, Python course Introduction to Data Science, Python course 2, Introduction to Data Science in Python. This is kind of an advanced course where we have a Python course 1, which talks about absolute basic level. So if you are a newbie, so I would want you to focus on that. And for today's purposes, we can discuss or we can go through the lesson number 2 of this particular course. So if you want to go through the course and what other options or what other analytics that we have and that we are going to focus during the course of this program is also outlined here. Some of them are star, so that requires, for example, subscription, and some of them are left open so that you can explore that, something like this and something like this for 24 hours so that you can make a decision about your subscription to the program. Okay, if I click on this link, so I'm going to get a page like this. So what does it tell you? So before going into the code section, I want to briefly show you how, for example, the lessons, coding lessons are organized in Omics Logic Learn portal. So they are always organized with the aim or specific aim or understanding the problem or introduction to understanding the problem as a first portion, right? So the aim of this specific lesson is to get an experience in data wrangling with Python and some useful data visualization in Python with which we can understand the trends, patterns, and relationships in the omics data. So that is what we are focused on. So we have a related video. It's very, very useful to go through that video. And this video is a small portion of sessions that you will be going through in a program like this. And then coming down, we have different sections and different areas which is described in the video and which is going to be focused for this lesson. Right? We are going to focus on how to plot using box plot or, for example, bar plot and scatter plot so that we can understand the trends, right? So each one of these plots, right, we can create as many plots as possible, but each one of these plot is going to give us some information about the data, about the pattern that is not going to be available in the other plot. So the choice of the plot becomes important in what are you trying to understand, right? And the choice of representation is also going to be important. For example, when you have a multi-class scatter plot like this, you cannot do with just using 2 or 3 different colors. So you should know how to access and handle different types of colors and how to, for example, stack plots on top of each other like this, so that you understand and compare the trends of whatever measurement that we have here, to understand which sample has different kinds of trend and which sample has this specific kinds of trends. The more focus on what data it is and how that is going to help us understand the sample distribution is going to be in the program. So for beginners, this is transcriptomics data, and this describes the gene expression difference between, for example, one type of sample compared to the other type of sample. Okay, let's go over and then come down. So this gives you a taste of how code blocks and associated discussions and explanations around the code block is organized in this particular lesson. Codes are always organized as these code blocks, which you can copy and then paste it in Python's environment to understand how they work and what they run. And most of the data that we are going to help you load and share is going to be shared with online based resources, like for example, based on our server. Sometimes you will find Dropbox link, sometimes you'll find GitHub link. So you don't have, it is not a data centric. You don't have to download this in your machine and then install some of the modules in the machine and go about it. So that is there. And for example, after this, what are we going to do to this data? So we are going to perform, for example, this log transformation. And how do we perform this log transformation becomes the focus of this particular code block. This is the organization of these lessons, right? So before jumping into this learn the code section, once you have gone through this learn the code section, which always follows the introduction or what is the problem or understanding the problem section, where you start appreciating the nuts and bolts of the necessary codes that we need to understand to make this aim of achieving or aim of getting a plot done, right? We start from as basic as importing necessary modules, right? And then go to what are the some useful functions that you can use to verify whether the data is loaded properly or not. And then, for example, one more library that we may need or we will definitely need to visualize. And then comes the code blocks, right? Like this. And then, for example, we give you properly commented areas. Sometimes they are here, for example, properly commented sections of a big blocks of codes, which will help you in pre-processing, which will help you in extracting relevant information from the whole table that you are going to focus on to load into Python's environment. So what I want to describe and what I want to demonstrate to you is, for example, after learning the necessary code pieces, right, that forms the center for understanding how to create a plot like this, right, and which is going to tell us what are the different gene expression patterns of 4 different sample types, right? You can then come down to practice yourself section, where you can practice what you have learned in the above section in here itself. You don't have to go elsewhere to test your knowledge or to test your understanding of how to have a code playground where you can write your own codes, or for example, complete the challenges that we have underlined and we have detailed for you to do, right? So what do we have here? So for example, we have the data, right? Due to the way in which Python is going to be installed and Python is going to be loaded in your browser, we have to download this particular input file. Let's do that. So how to do that? You know how to download this file. So you always save link as and place it in any folder, let it load. Okay, let's put it here, save it. Okay, I already have it, that's okay. So replace it. So first download this file available, says it, okay, we deleted. Yeah, so what is this focus is, we have, for your practice, once you have gone through the code section, we have deleted some of the syntax and some of them are left incomplete, so that you can understand by completing them the how different areas of this code will come together to help you achieve the necessary goal, right? Okay, this doesn't need any file. For example, Let's see if there is anything problem in this particular code block. I'm just loading the packages here. Let's see. It will take a little bit of time to load because Python actually works as being loaded in your computer's environment, and your computer is always influenced by whether you are sharing the screen, whether you are part of any other, whether you are running any other analysis, or how much memory you have. Exactly. Okay. Once you have completed, you say that you are successful in running the code, and then you have achieved the achieved completing this particular task. So this is very simple of loading the necessary data, necessary packages. But this is going to be a little bit challenging, where we have left some of the portions incomplete. So after going through today's session and after going through this code, I want all of you to try this and see if you can complete some of the easy or some of the straightforward challenges and some of the challenging challenges or more hard challenges, which are going to be focused as you go along in this test your knowledge area, right? And finally, you have the complete code where you can, for example, change some portions of the code and use this as a proper code playground to understand. We'll come back to this hopefully when we have some time. Let's see if this needs any difficulty. Okay, let's run this. Okay, so there is an error because there are some incomplete areas in this code. For example, what is the incomplete areas? Let's quickly take a look at. This is fine. This is fine, and this is fine. For example, auto show is fine. Oh, this is okay. This is only log. Okay. Okay. There is okay. Print log scale transform data. Okay, there is some error in this one. Okay, sometimes even though some of the codes are correct, this might give you some hiccups because of, as I mentioned, the Python is actually loaded in your computer, and that is prone to some issues. So for this purpose, today we will focus on how to take some of these codes and explore how to run in a Google Colab environment. So quickly give me a 1 or yes if you know how to access and how to understand understand running a Python code in Google's Colab environment. So if not, then let's take a quick look on that. So let me give you a link for opening a Google Colab. This is okay. Thank you very much. I think both of you are slightly experienced. From your responses, I learned that. So this is a Google Collaboratory notebook, right? So what is this used for? This is an online version of Jupyter Notebook, which you can load it in your computer. Jupyter Notebooks are notebooks that will run Python's codes in your computer in your own browser. But this is exactly the online version of that. So let's see Colab.2, whether this one will work. Okay, it's not working. Okay. Open new notebook. Oh, this is what we want, I think. Okay, you can probably take a new notebook here. Check if this one works for you, or if not, you might have to open only collab.research.google.com and then open a new notebook from this. Okay, like this. If you do this, if you do this, it's going to ask you like this, and open up a new notebook from here. Yes, open a new notebook from here. If you get this link, I think that's the best way to open a Python Colab notebook. So open this notebook, everybody. Let's go over some of the codes that we want to discuss today. Just quickly give me a yes if you are seeing, or okay, I close it. New notebook. If you are looking at a screen like this, let it load. An empty screen with one block. So some of the advantages of using something like this. So quickly give me a yes if you see if you're looking at a screen like this. Some of the advantages of working in Google Colab-like environment is, for example, you can get a link of this Colab and share it with your peers, share it with the mentors, and see and ask for feedback on your assignments or on your codes that you have tried, right? My first Google Colab. Okay, so give it a name. So give me a quick in the chat. Were you able to load this up and look at this particular screen? Yep, great. Some more responses. So we know some people who have experience in loading this up, and they are going to be a little bit ahead of you. I want some responses from people who are starting. Can you open this up quickly? Others? Let's get some. Thank you, Uzma, and others. Okay. So once you see such a screen, you have to connect, right? You have to connect to let Google allocate some resources so that you can run some Python codes. So it is initializing, let it do. So once you connect, you will see a screen like this. Then you can run your block. So what are we going to run? So let's go to our Python lesson. And in the learn the code section, so we don't want to go there, we go all the way down to learn code for data manipulation and visualization, right? So here we are going to use omics data to visualize what, how to, for example, make a plot like this, and what does this mean, right? And what does this mean, right? So why does this look like this in first case, right? So these things we will definitely discuss today quickly. So for that, as I mentioned, we have to import some of the modules. So in Python, nothing works without importing modules. So take this, copy this particular section. I hope you know where to take this from. If not, then I'm going to paste it here. Copy the ones that I pasted to you, and then inside this is a code cell. Okay, you have a code block and you have a text block. This is a code block. How can it tell this is a code block? A code block always has a run this block or run this cell option on the left, right? We cannot run anything that does not have any input. So I'm going to paste this, paste it, and then I run it. So this is simply importing the module. This is not going to give me any output. So when if you are here, then that's good. So you have imported pandas and you have imported NumPy in your Python's environment. So quickly run and give me a yes that you are here. We are going to copy the next block of code and understand what that code actually gives you. Thank you, Koi. So how to open another cell, right? You can obviously press enter, and keep running multiple times, but we don't want to do that. We don't want to execute the same piece of code that we have done executing. So we want to open up another cell. Next cell can be opened up by hovering here so that you can get this code option, or keeping this particular cell active and then inserting a code cell below. I have inserted a code cell below. So what do I want to take? So I want to take, okay, let's load a transcriptomics data and see what's inside the data. So that's what it is. This block is. So copy this. So this block will actually help you load a transcriptomics data. So what do we have here? It's pretty straightforward. So we are just using the pandas library and read underscore table function, and inside the read underscore table function, we are going to give this one necessary input that it always needs, right? The location where the file, where we have the file. So you remember this is a cell lines expression that we have downloaded. So we have not gone through that downloads at all. So let's see if I can actually download, if I can actually show you what does that look like. So this is what a typical expression table will look like. So so you will learn about what these are and how to understand different portions of this table in the program. But for starters, I'm going to show you that, for example, any expression data or transcriptomics data that is shared over the internet from publications, from repositories, processed data from repositories is going to organize like this. We have genes along the rows, and we have samples along the columns, and their gene expression measurement or quantification is going to be populated in each and every cell. So this is the information, or an information like this is what we are going to load in Python's environment. So let's go back again here. And this is the location where we have the input file that you can load. And once you have loaded this and loaded this file and saved it into an object called gene expression, that object is a data frame, then we can look or peek into the first few lines of the data frame using this head. What is not opening? You should not open it. You just copy it and paste it in the next cell and run it like this. The file opening is actually I gave you as an example, so you don't have to worry about that. Look at this. When you execute this code, we can peek into the table in Python's environment itself. So what is the issue, Uzma? So you don't download and open it. That's enough. I just downloaded that particular file and showed you how an expression table is going to look like. So you copy this and paste it in the cell, and then take a look at the first. That's okay. Take a look at the first few lines, just like how we have observed in the other expression table. This is also another expression table where the gene IDs are the ensemble IDs, and they are populated as rows, and the sample IDs are samples are populated as column, and their expression values are in the format of FPKM. You can actually find what FPKM in the relevant lectures when we are discussing this particular session. Okay, let's move forward. So we have loaded the file into Python's environment. So what do we learn from that? Right? And what do we have to do? For example, we can use this option, right, to describe some statistical properties of our data frame that we have just loaded. So you copy this. Okay, not this. You copy this and open up another cell and paste it. Okay, sorry. I think this thing got. Copy this, or you can type. Right. Okay, paste it and run. What do you see if you run? What are these? Can somebody tell me? So not only running the codes blindly will not help us. We have to understand what these outputs mean in the context of omics data, right? And that is also going to be discussed in the session. I'll give you a sneak peek. For example, these are all the statistical description or parameters of each and every sample, right? For example, take the first sample. There are something like 20,000 counts in the first sample, and we have a mean value of 42 and standard deviation, etc. We have a minimum of 0 and a maximum of 15,000 something, and we have a median of 4.3. What does it tell? Right? These are just bunch of numbers, but what does it tell? It tells some important story. So it tells that my data is hugely imbalanced, right? Skewed. Let's not say imbalanced. It's not imbalanced. It's skewed. So I have a minimum value of 0 and a maximum value in the range of thousands, but my mean and medians are completely out of sync, right? In any normal distribution or a distribution that follows Gaussian distribution, your mean and median should be very close to each other. My mean and median are extremely different. So that tells that my data is heavily skewed, right? So that is an important information that you can learn from this. Omics data are sometimes heavily skewed unless and until they are normalized into some form of normalization. You are going to look at heavily skewed data. Sometimes we use the data as it is required by some of the analysis, but sometimes we have to normalize it so that we can pass it on to the relevant analysis methods. So let's go forward. So what are we going to do? So to understand, for example, not just looking at the data in terms of number, we can plot. So let's take this and then open up another code block and plot the file, plot the data. So what do we see here? We are just plotting it as a box plot, right? So how do you plot as a box plot? You just type the name of the data frame and then plot.box. And if you just leave it as it is, then you are going to get some values. So I want you to try that option also. Let's try that option and compare let's open a code before this code like this. So I'm going to just write gene expression dot plot dot box. So if I run this, so what do I get? Right? So I get a normal plot, a box plot with some parameters or with some display parameter settings by default, right? If you look at our sample name, we see that our sample names are long, right? So the sample names are overlap, and it is hindering from us to understand which distribution belongs to which sample. So that's why we are rotating the x-axis labels, x tick labels by 90 degrees so that we can read them. And then we give a title for this box plot, right? The title is also not bad. So you can keep beautifying by giving a color and etc., which will be discussed in other sections and other areas of this particular lesson. Okay. I have been going yeah about this box plot for last 2 minutes, and there is no box. Can somebody tell me why is that the case? We know what a typical box plot will look like, right? A typical box plot will look like this. If I can find one. Okay, this is a box. Okay, a typical box plot will look like this. Yes, thank you. I think typical box plot will look like this. We have this box representing that 50th percentile or 25th to 75th percentile of the data, or majority of the data distribution is here, and we have median here, and we have 95th percentile here, and we have 5th percentile here, and we have some of the other data that lie beyond this distribution of 5th to 95th percentile of your data that are displayed as markers. In box plots language, these are called outliers, but in omics data analysis, these will become significant gene expression signal that we will base our analysis on. So in box plots language, they are called outliers, and they are described, or they are actually depicted as markers. But due to the data that we are dealing with, which is heavily skewed, they are not outliers as such. They are outliers technically, but those outliers are the necessary signals that we need to understand the pattern that is present in our data. Okay. This is what we have. So the same plot, we have used some interactive plotly option to describe it in this way. So the boxes are actually concentrated here, right? Just as I cannot pronounce your name, sorry, Masabati Azad, right? Can I call you Azad, right? Yeah, thank you. As Azad mentioned, rightly mentioned, they are concentrated here because of the skewness of the data. And some of the hints to the skewness of the data can be observed here also, as we discussed. For majority of the data, we have the maximum values in the order of tens of thousands. That's what we see here. And we have mean and median values concentrated in the order of tens or fives or something like that, which is what here. So this happens because of the skewness of the data. And one of the way in which you can address this is by transforming or by transforming your data into a logarithmic scale, right? And how do we do that? For example, we take the same code, right? Just add one more option of, for example, take next code, give a message here, right? Copy it and paste it here. So what is the difference between this code and the previous code? We just say whether or not do we want to scale up the y-axis in a logarithmic scale. That's what we tell here, log y, right? Scale the y-axis, that's where the y is coming from, and to a logarithmic scale, and we are going to use the option as, or we are going to give the option as true. When you do that, or when you perform this analysis, we get this distribution. So obviously this is not an interactive, but we understand the sample. For example, we understand that all of the samples have very uniform median values. They have very uniform expression, general expression average, but their distributions are different. For example, the majority of the distribution here ends at here, this point, but this is longer and this is even longer, right? And the outliers or the significant signals that we will be focusing on during the statistical analysis part is also different here, right? So that's what we can understand from here also, right? You see, some of them go as high as 16,000 and some of them stop at, for example, at 8,000. So these things are very, very important when you are comparing the expression patterns of, let's say, this sample with respect to this sample. So those comparison can arise from such exploratory data analysis. That's why we have to explore our data. Okay. If you want to work with some, for example, interactiveness of this plot, you are most welcome to try it. Okay. So what do we do next, right? We can, for example, go along and use these options to, for example, stack one gene on top of another gene, so that we can understand that particular gene's expression pattern across the sample. So this gene is expressed approximately similar pattern across the different samples, except for one or two, which can be they can be expressed at a higher rate. But this gene is completely, or we can even say one step higher, this gene exhibits characteristics that are statistically significantly different from this particular gene. So we can understand, we can do similar analysis and print out these options like this. And you can also perform scatter plot. So I want all of you to go through this whole lesson, right? This is a very useful lesson where you can understand different ways in which you can simply plot a table of numerical values to understand their pattern. Forget about what they implicate. The implication part and relating that to the biological phenotypical characteristics of the data and biological conditions under which the sample is measured will be discussed in detail during this program, during the session. That's what you will learn. Take these standard methods of visualizing any numerical matrix or a data frame or a table, right, and understand their important outputs in the context of biological or bioinformatics data, right? Like what we discussed here. In any box plots language, these are the outliers and they might be subjected to ignoring or completely discarding them. But for us, as I mentioned, these will form the basis of significant signal based on which we will understand the groupings of samples and sample difference. Okay, for some of you mentioned that you are not as experienced in Python and programming generally. So I'm going to show you, for example, how to, if you fall into that criteria. So instead of accessing Python course 2, you can go to Python course 1. This Python course 1 has a toned down version of same visualization and data wrangling part, where we are going to focus only on, for example, some of the things that we discussed today, right? So you can, Sonalika, can you please check the embedding of this particular plot, which is not available? So this is a very short introduction to data visualization using Python, so that you can obviously try. So if you are a beginner in Python, I would want you to go through this lesson first, and this is also left free for you to explore 24 hours. And after that, once you feel comfortable, after that, you can go to the advanced visualization course and data wrangling and advanced visualization lesson as described and as referred in the program resources. Okay, with that, I can actually ask if you have any questions regarding how we can access the associated resources and what we actually experienced today, right? And I also spoke about, for example, sharing your Colab, and this is how you do it. For example, this is a kind of example data wrangling session that you will actually get to work with in each and every session. I will walk you through each and every code, just like what I did here, right, to various different methods and creating various different plots and discussing everything, right? Why do we need to do that, right? This is what we discussed today, and different methods of creating that plots, right? And what are the different ways in which, for example, we can make groups of this, right? We can create like this also. This is what a sneak preview or sneak view of what you are going to get for the second session. Okay. And once I am done discussing this with you in the live session, then we are going to share this collab with you, right? And we will copy this link and share it with you. So once you get this link, and you can open it and make a copy like this, save a copy in Drive, and that copy you can use and you can edit the codes, run the codes so that it is getting saved, and practice what all we have discussed during the sessions lecture. So this is what we will share. And if you have some practice collab, and if you want to share it with me, share it with our team to understand what you have gone through, and if you have some difficulty in, for example, in executing some of the commands, right? For example, let's say I have an error in this particular one, and I don't know what is that error, then I can, for example, block this and comment, right? Error, please help me fix it. And then once you did do this, you can go to share, right? You can go to share and change the appropriate permissions, like, right, anyone, yeah, restricted, anyone with the link, and anyone with the link can actually comment or sometimes edit also. So we need editor permission so that we can edit your codes, right? And once you have done that, copy the link, right, and run it, and then send that link to support@pine.bio, right? Support@pine.bio. So that will reach us, and it will reach our team, right? Not only myself or not only the mentor, it will reach our team, our technical team, it will reach the CEO, it will reach everybody, so that everybody can have access to your code, and some of us will respond within a span of let's say 8 to 12 hours, right? So that way you can stay updated with the sessions that we are discussing and practice on your own. Share your assignments with us. Sometimes some of these collabs that we are discussing will come with some test yourself challenges or practices or assignments that you will need to go through in order to complete your understanding for that particular session. I think I have gone a little bit overboard. I will hand this session back to Sonalika, I think. And if you have any further questions, please type it in the chat box. I'll be happy to tend to that. Okay. Thank you, and hand it over to you, Sonalika. Are you there?
Yeah, sir. Thank you so much, Dr. Raghavendra. Yes, for the hands-on session. So I'll quickly guide everyone, whosoever is in the session, with the registration process and the resources. So hello everyone, my name is Sparsh and I am the marketing manager here at Pine Biotech, and I'll quickly guide you all through the resources and the steps to register for the program. So this is the program page, as you can see on my screen. I'll just quickly copy paste the link and share here in the chat box. Thank you, Shubham, for sharing. Now, the program is going to commence from 28th January, that is on Friday this week. And those who haven't enrolled in the program but has only registered, please, the date is fast approaching, enroll yourself. And we are right now giving up to 50% scholarship to all the candidates. So if anyone is having any query regarding the scholarship, Shubham, our representative, would be sharing the details, and you can ping us at that particular contact or the mail address, and we will accordingly guide you. So when I scroll down, there is a program overview, and in this program overview, we are giving you a brief that what all things we'll be covering in this program, how different modules are designed. So in this particular coursework, we will be covering practical as well as some conceptual aspects of machine learning, and in aspects to the biomedical data using some different tools of Python, etc. So now you will scroll down, you will find on your left hand side an interactive session, a calendar where there are some dates highlighted. Sorry, where there are some dates highlighted. So the first session is on 20th, as you can see, then the second session is on 24th, then the third is on 27th, 31st, and so on. So, and on the right hand side, you can see that the first session is on introduction to the program, and the topics which we'll be covering in this session would be introduction to the program, the objectives, the syllabus, the training resources, coursework, Google Colab notebooks, recordings, overview of big biomedical data, omics, etc. And with per session there will be some associated resources or links which we will be sharing with only the participants of the program who will enroll themselves. So as you scroll down, you can see then the second session would be on data processing and exploratory analysis. The third would be on machine learning methods, unsupervised and supervised types of the analysis, and so on. So in the end, we will be concluding this program on how you can design your own project once you have gained all the theoretical, conceptual, as well as practical knowledge of the biomedical data science in Python. So how you can design your own project using this, and finally, how you can submit that particular project in a good peer-reviewed journal and get it published. So moving further, you can see here that there are three different tenures in which you can enroll for. And one is 45 days, another is 60 days, and then is 90 days. First of all, I'll tell you the common resources which you'll have access to when you enroll in this in the program. So the common resources, as you can see here, is online tutorials, project examples, cloud pipelines access, coding sessions, session recordings if you by any reason didn't join the live session. So we'll be sharing the session recordings as well with the participants. Online mentor support and online technical support via WhatsApp groups or maybe Skype group or maybe Telegram. Then the certificate after completion of the program. So these are the common resources which you'll have access to. Now, what's the difference between the three tenures? In the 45 days tenure, you'll have access to the training material, training part only, where you will get full-fledged training on data science, on Python, how to use it, etc., and how to finally draft out your own research project out of it. In the 60 days tenure, you will be having two different opportunities. One is the one-on-one mentor support, and second is the extra time to work on your research proposal and present it to mentor for evaluation purpose. So by one-on-one mentor support, I mean that, for example, by any XYZ reason, you are not able to join the live session, and you were going through with your training material, your module, your curriculum, etc., and you get stuck somewhere. So you can communicate with any of our manager, maybe community manager or project manager, technical manager, and fix a kind of a 20 to 30 minutes exploratory call with the mentor and get your queries clarified. So this opportunity is there in 60 days. And the second is, once your 45 days of training is over, you can draft a research proposal, present it to mentor for evaluation purpose. Mentor will evaluate your research proposal and will guide you accordingly if there are any changes or amendment need to be done. If not, then you can proceed further with the experiment, with the research project development. Now, in the 90 days tenure, you again have two different opportunities. One is obviously the one-on-one mentor support. The second is the extra time to work on your research project. So the first 45 days will be devoted to your training part, and the second 45 days will be devoted to your project work. That is your research project. That is how you can develop your experimental design and then finally implement it. So the outcome of 60 and 90 days is a poster presentation in a research symposium or any international conference, or if you want to get your paper published also, then definitely you can get it published in a good peer-reviewed journal in 90 days tenure. So as now moving on with the pricing part, the pricing which you are right now seeing on my screen is in Naira for those participants who are right now in Nigeria or in African community. So the for 45 days it's Naira 49 50,000, then for 60 it's Naira 1 lakh, and then for 90 days it's Naira 1,50,000. And simultaneously, if you are from any other location, for example, if you are from USA or you are from India or from Europe, you can accordingly change the currency according to your location and see what is the fee for the program. For now, I'll just show you in Naira, in USD, and then in INR. For US people, it's $150 for 45, 300 for 60 days, and then for 450 for 90 days. And when you scroll up, it's INR. Okay. So just a moment. So it got automatically logged out and it's not getting login. So no problem. So for INR, the pricing for 45 days is 7,500 rupees. Then for 60 days, it's 9,000. Sorry, 10,000, and then for 90 days it's 15,000. And right now we are providing with 50%, like up to 50% scholarship. So those who are interested, please share your email address in the chat box, and we will definitely get back to you and will revert with the solution and the scholarship which we can eventually provide to our participants who are interested and willing to join the program. So this was all about the pricing part. I'll just quickly show you the pricing in INR also. So for 45 days, it's 7,500, for 60, 10,000, and for 90, 15,000. So this was all about the resources, the registration part, the fees in 3 different locations. You can change your location and pricing accordingly. Now, if you'll click on this buy now button, for example, I want to go for 90 days, I'll simply click on buy now and I'll be redirected to the payment checkout. I'll simply write here the coupon code, whichever coupon code we'll be providing you according to the scholarship, filling out the user details, clicking on this checkbox, and then moving further with either Stripe payment through credit card or via PayPal. So this is how you can proceed further with the payment also. And we are having other alternative options also for the payment process. It's UPI, it's bank transfer, etc. So if anyone is having any query regarding the registration process or scholarship, please feel free to ping in the chat box. And yes, we will be sharing the recording also with everyone by tomorrow. Thank you. Yeah, so okay. Perfect. So those who have shared their email address, we will be getting in touch with you by tomorrow morning, according to your time zones, and we'll guide you accordingly how much a scholarship we can provide with you. Is there any mentor guided course for transcriptomic analysis? Yes, Ahmed, there is definitely a course on transcriptomic data analysis, and you can mail me regarding your requirements at marketing@omicslogic.com, and I can provide you with an appropriate link. Yes, thank you. What are the general criteria for obtaining these scholarships? So once we'll get an email from your end that yes, you want scholarship, so we will be sharing a scholarship form with you. You need to fill out that form and we will discuss with our internal team about the scholarship, and then according to maybe if anyone is from a low income country, or depending upon the reason, will decide some scholarship. And also in some cases, we talk with the PIs or the faculty or the reference they have given in the scholarship. So yes, this is the criteria which we follow for deciding the scholarship. I hope I answer your question, Azad. You're welcome. If anyone is having any further question, please feel free to ping. Thanks, Shubham, for sharing the steps to register. So Shubham has already shared the steps to register for the program, and you can like paste these steps somewhere and follow according to these steps. Follow the registration and enrollment part. So the prices I just showed you for the program, these are without scholarship. Azad, these are not with scholarship. So yeah. Ahmed, it depends. We do provide 50% scholarship, and by like, I guess, 10th or 15th of January, we were providing with 50% scholarship only to everyone, not only a particular student, a participant, or joinee, to everyone. But it depends. So you can simply mail me and we can tell you the coupon code after filling out your form. We'll review your form application and then we'll get back to you with the coupon code. You're welcome. Are there any more questions? If not, then I guess we are good to go. And I hope I see maximum of you in our very first session, that is on 20th January, and brainstorm more about Python. So perfect. I guess there are no more questions. So thank you everyone for joining and looking forward to see you all in the first session as well as participants. So thank you everyone. Take care and bye-bye.